When it comes to underdog planets, Ceres is on top of the list. Yes, we've heard of the story of Pluto being demoted from a planet to a dwarf planet, but it is not the only one on the list. Welcome to Ceres and welcome to What the Math. This game is Space Engine, and today we're going to be talking about dwarf planets, specifically Ceres. But also we're going to be talking about a mission that you've probably never heard of before, a mission called Dawn. A mission launched by NASA in 2007, which is what we're going to be exploring today. In today's video, we're going to be talking about the Dawn mission. This is a NASA mission that was actually launched about 7-8 years ago in 2007. And it was a mission to explore Ceres and Vesta, the two dwarf planets. Actually, no, not dwarf. One of them is a dwarf planet, and Vesta is unfortunately still not really considered to be a dwarf planet because it doesn't meet the requirements. And I'll explain to you why in a few minutes when we actually get to that point. So this is the mission that was launched by NASA in September, on September 30th of 2007. And in 2015, it actually reached one of its coolest moments where it actually finally reached Ceres, and we got to see some pictures from Ceres. But unfortunately, that mission was overshadowed by another mission, and that mission was, of course, the Pluto encounter. And before that, in 2014, it was also overshadowed by the encounter with a comet. We had a mission from ESA, from European Space Agency, which unfortunately was a little bit too more exciting than this particular mission, which I think is also cool. So people should know about the Dawn satellite, the Dawn mission, because it's absolutely amazing. So let's actually start by we're gonna actually start from here. We're gonna create a new solar system in 2007. We're gonna start paused, and this is going to be our mission to Ceres and Vesta. So let's start this, and we're gonna click create, and we're gonna start the game paused, and here we are. So the first step for this mission was to well, first of all, to launch, of course, our spaceship, which we're gonna do by basically just adding it into orbit around Earth, and I believe it is right here in objects. So we don't actually have Dawn, but we have New Horizons, so we're just gonna add that at approximately, I don't know, 10,000 kilometers above Earth, and we're going to rename it to Dawn. Now this mission is actually, it's very interesting because it was cancelled 3 times. In 2003, when it was already almost finished, they decided to cancel it because there was just no interest and no money to make this satellite. Then it was actually relaunched in 2004, but canceled again in 2005. And finally, third time, it was launched in 2005 again. But in 2006, NASA said, okay, listen, there's just no interest and we really have no money. So the company making the satellite said, well, listen, we'll make it anyway, even though it's so expensive and it's going to cost us money. And this company was called Orbital Sciences Corporation. So we're actually kind of thankful to them for making this happen after all. So after all of these delays, after all of these problems, in 2007, on September 30th, Dawn was actually launched into orbit around Earth. So here we need to reach our escape velocity, and we're going to do this by basically just going into motion right here and changing the escape velocity. And our first destination is not actually Vesta or Ceres. Our first destination is going to be Mars, because for this mission, this satellite was actually, well, it actually had something else. It was the first satellite from NASA to actually actively use ion engines, using xenon propellant and ion engines to essentially increase its velocity in space. Now, ion engines have been used before by NASA and also by the Japanese Space Agency, but it was never used in such a fashion where it was actually an active engine meant for propelling the spacecraft into space. So as soon as this spacecraft is going to reach its escape velocity of about 42 kilometers per second, this is a total velocity, not relative velocity. Relative velocity is just over 11 kilometers per second. And then basically, as soon as we leave the orbital pool of our planet, we're going to reach the escape velocity. Now here I need to enable orbits, so we can see where we're going. And we're trying to get in rendezvous with Mars. So basically what we're going to be doing or what this spacecraft did in 2007, for the next 2 years, it actually flew toward Mars, because that's how long it takes to get to Mars. It then used Mars as a kind of a gravity assist. So in this mission, we're going to be trying to recreate that. So, ooh, it's going a little bit too fast. Where is it? Here it is. So let's see if we actually escape Earth, and then we're going to readjust our trajectory as needed. So this spacecraft used 4 xenon engines, which actually added about 10 kilometers of delta V per second. What this means is that it could change velocity by 10 kilometers per second in space, which is actually the highest ever. No other spacecraft ever had so much velocity change, or delta V basically. And in other words, this was one of the more advanced missions to date, at least from NASA. And the trajectory that the spacecraft took looked something like this. It would actually launch directly from Earth, and then for about 270 days it used its ion engine, which actually isn't very powerful at all. It only has the power of approximately 90 micronewtons, which is ridiculously low by engine standards. But for space, it works really well because it's very, very efficient. So for about 270 days right here, it would actually use its engine to increase the speed by about 1.5 kilometers per second. And then somewhere in this vicinity is going to meet Mars and then use what's called a gravity assist or slingshot maneuver to increase its orbital velocity even further. So this is what we're going to try to recreate right here before we continue. Well, yeah, like I said, the xenon ion thrusters, which the spacecraft used, were used or have been used before by the Japanese to encounter a comet, which unfortunately wasn't actually publicized in the Western media, but also by NASA earlier on. Let me just decrease this velocity a little bit. But yeah, also by NASA during its Deep Space One mission. It uses something called N-Star technology, which basically is referring to these particular ion engines that have a very efficient way of using fuel. Now, this spacecraft brought about 500 kilograms of xenon, which is the main propellant for ion thrusters, and this was enough to propel it, or to change its velocity by about 10 kilometers per second. Now, 2 years later, on February 17, 2009, Dawn mission was able to use Mars for a gravity assist. So right here, we're going to be passing by Mars really, really fast. It actually passed by about 500 kilometers away from Mars, and use the gravity assist to get additional velocity, a few kilometers per second velocity, to get into orbit that would then take it to the next destination, which is of course Vesta. So its first destination was Vesta, and its orbital path changed to look more kind of like this, where its orbital path intersected with the Vesta's orbit, so that it could then use its ion engines to try to get into orbit around Vesta. So for the next 2 years, until 2011, the probe used its ion engines to increase velocity a little bit more and to use a few more adjustments to get it into the intercept orbit with Vesta. And the interesting thing is that on the way to Vesta, this spacecraft experienced quite a lot of mechanical problems. Its antenna would not work, its ion engines malfunctions, and there was quite a lot of issues with the spacecraft, specifically the software on board, that really caused headaches to a lot of NASA engineers. So this is probably one of the reasons why this spacecraft didn't really get as much attention as the New Horizons probe or even the ESA mission to the comet, more commonly known as the Rosetta mission. Alright, so anyway, so in 2011, specifically July 16, 2011, Dawn spacecraft had an encounter with Vesta. Now, it actually passed by it and used its ion engines and also its thrusters to get into orbit. So right now we're going to try to get into orbit around Vesta by decreasing our speed dramatically. So between July and August of 2011, Dawn spacecraft was actually captured by Vesta's gravity, and it started orbiting around it. First with a higher orbit, where it spent some time to basically kind of take farther away pictures and to start investigating things like atmospheric field, if there was one, and gravitational fields and so on. Then, in December of 2011, it decreased its orbit a little bit and actually started orbiting a little bit closer to Vesta to get more higher resolution pictures and to get a better view of Vesta. And between December and May of 2011-2012, it basically spent most of its time orbiting in a very low orbit around Vesta, taking a lot of really nice high-resolution pictures and exploring all kinds of mysteries of Vesta. Now, the reason why Vesta was really interesting to us, or specifically Vesta and Ceres and not any of the other objects in this particular asteroid field, is because Vesta and Ceres, they're the largest objects. So Vesta actually takes up about 10% of the entire mass of this entire asteroid field that orbits between Mars and Jupiter, and Ceres is 3 times more massive. It actually is approximately 1/3 of the entire mass and is also bigger and cooler looking as well. So Vesta is actually an asteroid, so it's not a dwarf planet, because even though in this game it does look like it's a spherical object, in real life it's not. When I show you this in Space Engine, you'll see that it's actually not a spherical object at all. Now, unfortunately, in this game, this hasn't been updated yet, but it does have a really interesting, a lot of really interesting features, including a very, very large crater right here on the southern tip that was created maybe 4 billion years ago by a really large collision. And because of this collision, Vesta lost about 1% of its mass, and all of this mass became tiny asteroids, tiny meteorites. And these meteorites very often make it to Earth. They actually are one of the most commonly found meteorites on Earth, and there's a name for them. They're called Vestoids, and they have a very specific composition that we actually have been able to study without even visiting Vesta. So we know a lot about Vesta just by studying those asteroids and meteorites. Now, Vesta is considered to be a kind of a dry and rocky place. So it's essentially what you would think of when you think of asteroid or meteorite. It's basically a flying rock, and it's the largest rock we know. And this rock is essentially the biggest asteroid that we currently know. Now, Vesta was discovered a long time ago, actually more than 200 years ago, and both Ceres and Vesta were discovered in early 1800s. Ceres was discovered in 1801 and Vesta a few years later, and when they were discovered, they were classified as planets. So both Vesta and Ceres were used to known as planets. Now, what happened was, as the new astronomers back then started to kind of look into the sky, they started to discover even more objects. There was a lot of objects in this particular area. And I'm of course talking about the area between Mars, which is right here, and Jupiter. So this area right here is known as the asteroid field. So a lot of really large objects were discovered in this area, and all of these objects started to be classified as planets. Now, astronomers back then, this was early 19th century, 1800s, they decided that, listen, we can't just name planets after planets, so we need to figure something out. And so this is when the term asteroid was born. So both Vesta and Ceres started to become classified as asteroids. Now, a similar story occurred in 2006 when we reclassified Pluto as a dwarf planet, because we started to discover these other objects flying past Neptune that were also large enough, but there are just so many of them that we couldn't name all of them planets, so we had to name them dwarf planets. But yes, so the story has repeated itself 200 years later in 2006, just like it was back in the early 1800s. But it was actually, both Ceres and Vesta, they were both considered to be planets for at least 40-something years, until 1850. That's when they were actually reclassified officially as asteroids and became known as a completely different type of object. Alright, so it's time for us to leave Vesta and go to our next destination, which is of course Ceres. Now, this is actually the coolest thing about this mission. This was the first time in history that a spacecraft, a man-made spacecraft, was able to reach an orbit of another object and then change to an orbit around another object. So not only did it orbit around Vesta in 3 different positions, it was then able to launch itself on escape velocity from Vesta, reach Ceres, and get into its orbit as well. So this is actually the first time this has been able to, we have been able to achieve this, and there are no future missions that are planned that will actually do the same. So NASA was able to reach a new milestone of space exploration with this mission. Vesta and Ceres, they have a slightly misaligned orbits. I'm going to show you what I mean by this. So Ceres is right here, and Vesta is actually right here. So it did have to use its ion engines a little bit more to be able to intercept Ceres. And here we go, on March 6, 2015, we were able to approach Ceres and start taking shots of this beautiful dwarf planet. These were actually the first shots ever of any dwarf planet, because this was before the New Horizons mission that later on in the summer of the same year was able to take pictures of Pluto. So This was the first time we took pictures of Ceres, and unfortunately it was actually underreported. I don't think many people heard about this Dawn mission to Ceres, or have seen pictures of this awesome dwarf planet. Here are some of the photos that we were able to take. And so for the next few months, this probe right here will or has basically explored various orbits of Ceres, taken photos, trying to calculate its gravitational field, and also looking at its atmosphere. So I'm going to zoom in here, because what we've discovered by orbiting really close to it is that it does have a very, very thin atmosphere, about 0.001% of atmosphere on Earth, but just like Pluto, Ceres also has a bit of an atmosphere. Now, unlike Vesta, this is actually known as the icy dwarf planet. So, actually, Vesta is not a dwarf planet, but anyway, what I'm trying to say here is that this is mostly consists of, or not mostly, but 1/3 of it is ice. It doesn't unfortunately show that well in the game because we are mostly here silicate, but it really should be like this. It should be there we go. This is looking better. About 35-34% of it should be ice. Now, I totally did not expect it to change its look like that, but it is essentially only about 60 to 70% silicates or rocks, and the rest is ice. And the interesting thing about it is that it may even have liquid water underneath it. So there might be an ocean underneath all this ice, and it might have liquid water inside, which of course gives us a possibility of having life on this particular dwarf planet. Anyway, so we're gonna go back to the original form, and I'm gonna show you something else. So, as the Dawn mission started to approach Ceres, the scientists started to discover these really awesome bright objects on its surface, which of course ufologists or people that study UFOs attributed to aliens. So like this one right here, and that one right here. Instantly people thought, oh no, aliens, we have to explore them. NASA is gonna hide things like that from us, right? Anyway, let's not talk about silly things, let's talk about the reality. The reality is that NASA scientists thought these were cryovolcanoes. In other words, they were like volcanoes of ice cold water and ices of all kinds. The thing is, we know that they exist. We've seen them on other objects, but we didn't really know why these bright objects are so bright and what makes them so bright. And as we approach Ceres closer and closer, we discovered that no, these are not cryovolcanoes. This is not ice at all. This is actually, and I'm gonna show you right here when we advance a little bit. This right here is actually a salt deposit. Yep, that's right. This is salt. Now, not the same thing as a table salt. But basically salts are a type of minerals, so kind of like magnesium calcites, magnesium chlorides. All of these are an indication that there might be liquid water after all, because usually salt deposits happen when there's liquid around it. And we also found a really cool mountain, which here's the picture of it. The mountain that is potentially a salt mountain, a mountain full of salt. So all these cool discoveries, atmosphere, salt, potentially liquid water, really gave us so many new ideas, so many new opportunities for studying dwarf planets. And unfortunately, none of these news were reported to us because the Rosetta mission in the late 2014 kind of overshadowed this particular mission, and later on New Horizons overshadowed it again. So we didn't really learn about Dawn mission or the trip to Ceres until now. Now you know about it, but I'm sure many of you did not know about it before. And interestingly, in about 5 years from this mission, specifically in 2020, the Chinese Space Agency is planning something even cooler. They're actually planning to send a sample retrieval mission from either Vesta or Ceres, but very likely from Ceres, to retrieve a sample from its surface, to essentially to land a spacecraft on the surface of Ceres, retrieve a piece of rock, and then bring it back to Earth. And of course, this is really exciting because it's actually only in about 5 years after the end of Dawn mission. Dawn mission is going to cease its operation in early 2016, and essentially Dawn spacecraft will just orbit around Ceres continuously and will stay in its orbit somewhere right here, a few hundred kilometers above the surface of Ceres, and will most likely stay there for thousands of millions and billions of years until something collapses into it, or until our sun explodes and takes it away with the other solar remains. So the Chinese space mission is actually kind of exciting because this will be the first time since the moon mission or Apollo missions in the 60s and the 70s that we'll be able to land on another object and retrieve a sample of that object and bring it back to Earth. So super exciting time to live in. But anyway, let's actually get out of Universe Sandbox 2, and we're going to go into Space Engine and explore the surface of both Ceres and Vesta in a little bit more detail and just kind of walk around there and see what it looks like, because unfortunately in this game the surface kind of looks flat. It's not really well represented, at least yet. So if you land on the surface of Ceres, for example, you'll just see flat surface like this. Not exactly exciting or realistic. So let's actually go ahead and launch Space Engine. And welcome back to Ceres. So this is what its surface may look like. Space Engine is absolutely excellent at generating surfaces of various planets, and so we're going to be moving around here and looking at it from different perspectives just to see what it possibly looks like. Now, Ceres is, like I said, is a very watery world. It's actually most likely to be a most watery world in our solar system. Water comprises anywhere between 15 to 30% of its mass, and a third of its volume. So, but it's very likely that when the solar system was just being formed, this was not the only such watery object, and many watery objects were the reason why our planet has so much water now, because many objects like Ceres may have collided with Earth to create Earth as we know it. And so the cool thing about Ceres and Vesta and Dawn mission that we've just talked about is that we were able to see what protoplanets were like. We're actually able to see what Earth may have been like billions of years ago and what it actually looked like. And we get to explore it, we get to see its birth. So Ceres and Vesta are, in a sense, kind of like the undeveloped or underdeveloped planets. They're also known as protoplanets, and right here we see a very large crater from an impact that happened probably billions of years ago that generated many other asteroids in the asteroid belt. The other interesting thing about Ceres is that I'm not sure if we can find it here, and I don't know if it's generated in this game, but there is actually a very large mountain, as I mentioned before. It's a mountain that is very likely to be made of entirely of salt or salt-like materials. And it's a mountain that is very geometrical in its shape. It almost looks like a pyramid. So I'm sure a lot of ufologists will once again think that it's aliens and it's some kind of a alien world. But science tells us that it's not that. It's very likely to be a deposition of different salts that does happen on Earth as well, but in much smaller proportions, because here the gravity is much lower. So it's very likely that this particular mountain was formed by a very different type of event. Anyway, let's fly around here. Let's actually get inside this crater, see what it's like inside. And as the game generates terrain, we'll get to explore it as well. We're also going to go to Vesta. I'm going to show you what Vesta looks like, because this game does a really good job at generating Vesta as well. And look at this beautiful landscape. This is amazing. Now, this mountain that unfortunately is not generated in this game, or at least I just don't see it, I can't seem to find it, is about 6 kilometers above the surface. So it's kind of similar to ice mountains that we've witnessed on Pluto. And it's very likely that it's possibly even the same type of action that deposits or makes these mountains, but we don't really know what it is yet, because it's a new phenomenon that we haven't seen before. So yes, this is maybe something that's very unique to dwarf planets and something that we haven't seen before on any other object in the solar system. So anyway, so this is Ceres, and we're gonna click on this right here and type Vesta, because this will take us to Vesta. And as you can see, it's actually classified as asteroid, whereas Ceres is a dwarf planet. So Vesta is actually not a dwarf planet, despite being in the same sort of region of space. So what I like about Space Engine is that it's able to generate some objects very accurately. And as you can see, Vesta is not spherical, which is why it cannot get into the dwarf planets club, unfortunately. To become a dwarf planet, you have to have enough gravity to become a spherical object. Now, for Ceres, it was actually a little bit easier, because it mostly contains water, and water and ices allow you to be spherical a lot easier than if you consist of rock like Vesta. And Vesta would need a lot more mass than Ceres to get into spherical shape. Now let's actually get into position where we get to see the southern crater of this object. I'm gonna try to find it, because this particular object is where this large impact occurred a few billion years ago, and I think it's actually possibly right here in the dark. I think maybe this is it. Maybe this is it right here. I can't really see the dark side, so I can't really tell. But this large crater, Let's actually just spin the object a little bit and see if we can find it somewhere on the surface. But yes, this large crater is the result of a very large impact from billions of years ago, which essentially generated a lot of these so-called Vestoid asteroids or meteorites that we often find on our planet. About 6% of all meteorites on Earth are known as HED meteorites, which are known as, or basically it stands for Howardite Euclide Diogenite meteorite, which is basically a type of a rock that is only found on Vesta. These Vestoids have a very specific composition, and we can essentially study the composition of Vesta by using these meteorites that once in a while fall on our planet. Now, I don't really see the crater. Maybe it's just not generated in the game, or maybe it's this right here. I'm not really using my imagination enough. But essentially, this is what Vesta kind of looks like. It's sort of a blown in its shape. It sort of looks like a flying egg, I guess. And it is the largest possible asteroid in our solar system, and unfortunately will never make it to the dwarf planet list. Now, if you've never tried Space Engine, you should definitely give it a try, because this game is absolutely free, and it is possibly one of the most amazingly unique space games out there. Now, it's really not a game as much as a simulation of the universe, and of course, all of these objects you see in space, those are all individual stars and galaxies and solar objects and stellar objects that you can fly to and explore at your leisure. In the new edition of this game, you can also add vehicles. You can actually add spacecrafts or get into spacecraft mode, or you can add a spacecraft. I think it's done by clicking on this right here. You can choose different spacecraft. So let's actually just choose X-Wing. Let's build it. Here we go. Here's the X-Wing. Oh no, I'm flying away from it. Come back to my X-Wing. And you can then essentially fly it as if it was a real spacecraft. So this is not Star Wars X-Wing, because that would be copyright infringement. But it is a X-Wing-like spacecraft that uses modern technology, and you can then fly this by clicking on this button right here, take control. And this will turn this into a space simulator. Look at that. We can now fly our X-Wing with Newtonian physics, and we can try to get around space and explore different objects. Now, so this is a Space Engine, and this is Vesta and Ceres. Hopefully you enjoyed this video. Hopefully this was informative to you, and now you've learned a little bit more about Dawn mission by NASA, which is a mission that was plagued by problems and errors and cancellations, but actually finally made it to Ceres and Vesta, and will complete in early 2016. Will actually be a successful mission, and should be just as popular as New Horizons. I don't know why it's not popular at all. I love that mission. Ceres is awesome. Ceres has been discovered in 1801, and we've known about it for over 200 years, specifically 214 years before we finally made our way to Ceres. Anyway, so let's fly away from Vesta using this beautiful spacecraft, and we're going to stop this video here. And look at that, Vesta is flying away into the distance. We're using our X-Wing to basically prepare ourselves away from this asteroid into open space. We're going to fly away into the universe and escape this solar system. Now, before I finish this video, I just wanted to thank all of you guys for being so awesome, for subscribing and for watching my videos, and for leaving so many positive comments. You don't know how much it means to me. I've gone through some really difficult things in my life this year, and it really, really helps me to hear that my videos actually help someone. Anyway, if you do enjoy this video, check out some of the other Universe, Sandbox, or Space Engine videos that I posted. I'm leaving the playlist link in the description. And definitely leave a comment if you would like to see more of these types of videos, or if you have any other suggestions for something Space Engine or Universe Sandbox 2 related. Alright, so we flew away from Vesta, and I'm actually kind of lost. I don't even know where I am anymore. I flew for a few minutes and got lost. I think Sun is somewhere nearby. We can possibly use Sun as orientation. And anyway, I'm gonna stop this video here, but if you would like to help this channel financially, check out the Patreon page that I've recently started. Patreon is essentially a way to support artists and the community, and any kind of financial support that you do provide for this channel will go into making these videos even more awesome, because I'm basically going to spend all of the financial support on in better microphone, better video camera, and also better rendering system, which will make me or allow me to produce videos even faster. Anyway, thank you so much, guys. You're amazing. I love you so much, and game you later. Bye-bye.